this alcohol will attack at the. Hello everyone, welcome to Plutus STEM. Today we are going to discuss regarding preparation of alkyl halide from alcohol. So in this method we are going to discuss these subunits such as from HCl plus ZnCl2, from PCl5, from PCl3 and from SOCl2. These are the four important way how which we can prepare the alkyl halide from alcohol. So those who are watching this channel regularly, they know that we have already discussed the preparation of alkyl halide from alkene, and in alkene we have discussed the various way through Markovnikov rules, through free radical mechanism, and many more like various miscellaneous reactions we have seen, various named reaction we have studied for this alkene. And today we are going to discuss regarding this is also a free radical reaction. So all this have been covered up in a quite detail in the previous videos if you are watching this. So those who haven't watched that, you can go through the previous videos. We have discussed all of them in quite detail. Today we are going to discuss regarding these four important reactions from alcohol to alkyl halide. This is ROH, alcohol plus some reagent. It is going to give RX, alkyl halide. The initial substrate is going to be this and the product is going to be this, and only the change which we are going to see over here will be this reagent. And I have shown you over here there are four different type of reagent which we are going to use in this today's class. So if you see the first reagent, HCl plus ZnCl2, how it is going to give the alkyl halide. For that purpose we are going to see over here this ROH when reacted with HCl in presence of ZnCl2, it is acting as a catalyst. Initially it will react, but afterward we will see that it will be relieved in the same way like it hasn't occurred in this reaction, which means it will participate in the reaction initially, and in the afterward we will get the same ZnCl2 will be leaving from the reaction. Yes. So this will give us RX. This thing from here, the simple way if you see, if you see over here, we can see RX is being over here and this H2O, water. So if we have taken Cl over here, so we can also write down over here Cl. So this is the general equation. How this reaction is proceeding, we need to go into the mechanism of this reaction. How this reaction is proceeding, so we need to see the mechanism of this reaction. This is ZnCl2. So what is going to happen over here? This alcohol will attack at the empty orbital of the zinc, empty, or you can say vacant d orbital of the zinc, and we are going to get this as a ROH ZnCl2, a positive charge over here. We are going to get a positive charge at this site. So now what is going to happen in this case? this OH positive, what it will do, it is having a slightly positive charge is there. So a positive charge is been generated because it has donated its lone pair of electron to zinc, and zinc will have a partial a negative charge. If you see over here, zinc will have a negative charge. So what we are going to see over here, to gain the stability, it will become like this: R positive. We are going to get a R positive plus ZnCl2. ZnCl2 OH. We are getting over here ZnCl2 OH, and with the help of this H positive ion, this is now neutralized. So what will happen now? The H positive ion of this HCl, the H positive ion of this HCl, it will be abstracted by this OH, and it will leave like this ZnCl2. So in this process we will get a ZnCl2 over here, as we have taken in the previous step, and this carbocation will be attacked by this this HCl part. So this Cl negative part will attack at this carbon, and we will get RCl, alcohol to alkyl halide, alcohol to alkyl halide. So in this process, the important step is this one, the rate determining step. This one is the rate determining step, the formation of carbocation. And we will also see how is the stability of this reaction is going to take place. This is the carbocation formation. This is our carbocation. Let's say all these bonds are in same plane. So what will happen now over here now? There is a possibility for this Cl negative which is attacking. So either it can attack from the above side, or it can attack from the below side. So there are two possibilities through which this Cl negative can attack on this carbocation. So one side attack will give us another product, and another side will give us another product like this. Sorry. This is our carbon. Let's say this is Cl over here, and another is Cl at this side. So two different side attack. If the two different side attack, one from this side, another from this side, because two positions are there. This carbocation is a planar thing. So one attack can be from the upper side, another attack can be done from the downside. So we are having two possibilities. If this is a chiral center, so we will have one R and another as S. This thing we have already studied in class 11 in quite detail. So we are not going to focus too much on this thing. So just we need to see over here one R and another S, which means two possibilities are there. And we can say that when two enantiomers are there in an equal proportion, then we call it as a racemic mixture or racemized product. Although the retention part is lesser in quantity than to the inversion part. Inversion is having a higher concentration or higher yield. Let's say this is our OH, and it is being reacted with HCl in presence of ZnCl2. So what we are going to see over here, we will see two type of product. We are going to see over here two type of product. One will be C3H7 C Cl. One Cl will attack like this, C2H5 and CS3. Another will be like this, C3H7 single bond, CS3, C2H5 and Cl. So these two product, one from this side, another from other side. So these are the two possibility due to the same phase for this carbocation. And if you see the stability of this carbocation, we know 3 degree carbocation are more stable than 2 degree carbocation that are less stable. 1 degree carbocation are least stable. So this reaction will proceed through 3 degree more prominently than 2 degree, and after that this reaction is going to proceed through the 1 degree. This type of reaction is also being used in the Lucas test, or this is also termed as Lucas reagent. This is also termed as Lucas reagent. This ZnCl2 plus HCl, and it helps in the determination of 3 degree, 2 degree and 1 degree alcohol. 3 degree alcohol will give the reaction within a seconds or fraction of second. This 2 degree alcohol will take some time, you can say 5 to 10 minutes. The reaction will proceed in 5 to 10 minutes, and this will not proceed. This reaction will not proceed at room temperature. This reaction will not proceed at room temperature. So this is the way how we can also test the different 3 degree, 2 degree alcohol by this simple reagent, Lucas reagent. So this was for this 3 degree, 2 degree and 1 degree alcohol termination also. So now we are going to move to another reagent, that is PCl5. So now we will see how this reaction will proceed through this PCl5. If this is our ROH alcohol, when react with PCl5, it gives RCl. It will give RCl and plus HCl plus POCl3. Three things are being, so this is a very important. Sometime in the question exam it is being asked to balance this whole reaction also. So we know that alcohol when react with PCl5, it give RCl, HCl plus POCl3. So if we see a bit, because the mechanism is not that much necessary for this reaction, but we will get a bit proof of this mechanism also, how this reaction is proceeding. This is like ROH, this is PCl5. These lone pair, they attack on this, and what will happen? This Cl1 Cl will leave from here. This 1 Cl is going to leave from this, and this reaction we will see that we are going to have ROH single bond P Cl 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 and Cl like this. But now you can see this bond is attacking at phosphorus and new bond is forming, and it is giving its lone pair. That's why a positive charge is generated, and the negative charge which should have been generated on this phosphorus has been taken by the Cl, and minus Cl is leaving from here. So in the next step, what is going to happen? Now we will see this Cl negative which is being leaved from here. What it will do? It will attack at this hydrogen, and we will have a product like this, RO PCl Cl Cl like this. One more Cl is there, yes, 4 Cl are there. Clear? So this is like HCl is being leaved from this reaction minus HCl at this step. So in the next step, what will happen? This oxygen, it is having a lone pair of electron, so it will try to do the conjugation, and this lone pair will come over here, and this Cl can be leaved over here. Okay, no, sorry. One, two, three, four. This Cl1. So what will happen? As soon as this attack over here, this Cl leaves an attack. Okay, sorry. This Cl leaves an attack at this site, this R. As soon as the bond break down, the same bond is being formed. This is a intramolecular reaction. This mechanism is intramolecular. Clear? This mechanism is intramolecular, and we are getting a product RCl, and this is P double bond O Cl3. So you can say POCl3 plus RCl plus HCl, or the three things. This is HCl, this is RCl, and this is POCl3. All the three reagents I have shown you that how these all reagents are being formed over here. POCl3, RCl, and HCl. This is in the case when we are having this PCl5 generally in the gaseous phase. Generally, this reaction happens in the gaseous phase. From a board exam point of view, this PCl5 is quite important that in the gaseous phase only. But when you go for this, and one more thing over here, here the stereochemistry will be, you can see retention in configuration. Over here, the stereochemistry will be retention, because I have shown you RO, PCl, Cl, Cl, and Cl. This bond is coming over here, and this bond is coming over here. This is breaking, and it is coming over here. So it doesn't that much time that it can leave from here and attack from the backside. It is an intramolecular reaction. So it will attack from the same side from where the O was bound. So that's why we will see a retention in configuration. Retention in configuration, or you can see intramolecular reaction. So yes, so now we will be seeing another type of reaction, that will be one more thing which I want to tell you. In the solid state, in the solid phase, or you can say PCl5, when in the solid phase, we are going to get a inversion product. We are going to get a inversion product, because this PCl5 exists in PCl4 negative and PCl6 positive. PCl4 negative and PCl4 positive and PCl6 negative. So in this form they are being formed, and this RO will attack at this PCl4, and this will leave down, and at this time in this we have seen the attack was from this Cl, but in this case the attack will be from the POCl6. So I will show you this also if you wish, how the mechanism in the solid phase. That is not for the board exam, just for a competitive exam point of view. This is also important for solid phase. PCl5, if you see ROH plus PCl4 positive. So what it will do, this OH will attack at this phosphorus, and it will get a bond like ROH and PCl, Cl, Cl, and Cl. All the four Cl will remain over here only, and what will happen now, this OH will have a positive charge, and this positive charge will be stabilized like this, and we will have ROPCl4. Again the same manner this bond will come over here, and this time what will happen, this Cl will not attack. Before this attacking of the Cl, the PCl6 negative, or we can say PCl5 plus Cl negative, this moiety will attack over here from the back side, and we will get RCl, and POCl3. This will come over here and this will also leave over here, this POCl3, and that HCl, H positive, will make a bond with this HCl. So final product will be like HCl, POCl3 and RCl. But we have seen initially that the whole mechanism is quite different. That's why in this case we will see the inversion in configuration. We are going to see over here inversion in configuration. So this was for like PCl5 we have discussed, and we have already discussed about the ZnCl2. So now we will discuss the next reaction, that is PCl3. With PCl3, ROH plus PCl3, ROH with PCl3 will give us RCl, plus H3PO3. H3PO3. So if we want to see the reaction is balanced or not, there are 3 Cl are there, so we can say 3 RCl. When 3 R are there, so we can like write down like 3 ROH. So 3 R, 3 R, 3 Cl, 3 Cl, 1 phosphorus, and you can see 3 hydrogen, and you can see 3 oxygen. So everything is balanced now. So this is the balanced reaction. Sometime in exam you need to ask to balance this whole reaction of this PCl3 separately and PCl5. So don't be confused. Both reactions are a bit different, although we are getting the same product, but these side products are different in both directions. So if you see the mechanism a bit, mechanisms are not that much important, just I am telling you that if this is ROH, when reacted with PCl3, this will attack over here, and what we are going to get over here, we will get ROH PClClCl like this. This was the way like ROH PCl3. So if you remember in the previous step, what we have done, we have removed this H. What we have done in the previous step, we have removed this H like this. To remove this positive charge, we have taken the proton, but as we know, the mechanism are made afterward. Firstly, we have know the experiment result. On the basis of the experiment result, the mechanism are being written. So we can see over here in this reaction what will happen. This ROH, this Cl, which is being over here PCl3. So now what will happen over here? This time Cl negative. When we have attack over here, this is like PCl3. So from here, one Cl is being leaved. Yes or no? So this Cl negative which was leave from here will attack from here, and we will get RCl. And product will be inversion in configuration from the back side plus PCl and OH. So this is the first step. In the second step, what we will see, this again the another moiety of ROH, it will react with that PCl2 OH. It will attack over here, and what we are going to get, the same thing will happen. This time ROH, PCl and OH. The Cl which was left from that side, this time it will attack and we will get a product like this. PCl, OH and OH. In the last step, again the first step part, second part and the third part, what is going to happen this time? This another moiety of ROH will attack at POH, POH and Cl. This will attack over here and this will leaves and we will get ROH, POH and POH. So this Cl which was left, now it will attack from this side and we will get RCl. So how many RCl we are getting in this product? First RCl, one RCl, one more RCl we need to get. From this side also we get this RCl, yes, plus RCl and third one we are getting from here. So 3 RCl we are getting, 1, 2, 3. So you can see from here 3 RCl. And PCl3 we have already used 1. This 3 ROH we have used first, second and third. So now we will see the H3PO3. This is our POH, POH, POH. It will rearrange and it will form a more stable H3PO3. This is the actual structure of H3PO3. So this is being formed from this whole reaction. So we have seen over here how we can prepare this from this PCl3. So now we will see one more reaction, that is Dalton's reaction. So this ROH alcohol when reacted with SOCl2. So when it reacts with SOCl2, so what we are going to expect from here? Again the product will be RCl. Product we are going to get is RCl, and in the side product we are going to get over here SO2. So how we are going to get these type of product, that we will see. The firstly we will see that this will attack like this plus HCl also, yeah. So how the reaction will proceed? This is our ROH and this is the product like S double bond O, Cl and Cl. This will attack like this. It will goes up and comes back and this Cl will leave from here. We will have ROH S double bond O, Cl. So there is a positive charge from here. This Cl will take this positive charge. It will become RO S double bond O, Cl. So now again the similar type of intramolecular reaction will take place. This bond will comes over here, it goes up and comes down, and this Cl will attack at this. We will get RCl plus SO2. And this HCl will leave from here. We have already get HCl. So HCl plus RCl plus SO2. This is the product which we are getting over here. And in this product also we are getting a retention in configuration. So if you want to know a deep of this stereochemistry, then you can move on to our class 11th lecture where we have discussed these SN1, SN2, SNI in quite detail. In that we have explained in a quite detail that how this process is SNI intramolecular, why we are getting retention and what is the retention. So this all thing have been discussed in class 11 stereochemistry chapter and in the reaction mechanism also. We have discussed these things in quite details. So now if we want to summarize this whole which I have told you in the today's lecture, the first thing which we have discussed was ROH when react with HCl, it gives in presence of ZnCl2 anhydrous, we are going to get RCl plus HCl. This is also a Lucas agent. If you don't want to do the mechanism thing, you can clearly make it like this: ROH plus, sorry, RCl plus water. Yes, sorry. You can cross check this if you have made this mistake in the, I don't think, while mechanism solving, we have made the water. Clear? So this is the first reaction which we have studied. The second reaction was ROH when reacted with PCl5, or you can write down like, yes, PCl5, it gives RCl plus POCl3 plus HCl. Third reaction was ROH plus PCl3 gives RCl plus H3PO3 plus HCl. The fourth reaction which we have studied today is ROH plus SOCl2 gives RCl plus SO2 plus HCl. So these are the reaction which we have studied. And the one more important thing which I am telling you, most of the time we are going to study regarding chlorine and bromine. Chlorine and bromine, we are going to study that these are being prepared with a very importantly from these all method. But except this SOCl2, we can only get chlorine, not bromine. From this metal, we are going to get only Cl, RCl. But from all other matter, we can get chlorine and bromine. For fluorine, if you want to get, for that we need a oxidizing agent. For fluorine, we need, for iodine, we need an oxidizing agent, such as HiO4. We need some oxidizing agent such as HiO4 because it is a reducing agent which is being produced while formation of this alkyl iodide. That's why we need some oxidizing agent to prepare this iodide. So that's all for this alkyl halide. In today's lecture, we have discussed in quite detail regarding this various formation of these from alcohol, various formation of these alkyl halide. In the next upcoming lecture, we are going to discuss regarding the formation of aryl halide. That's all for today. Thank you.